Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've derived the OVB formula and worked out the direction of the bias. Now let's make that structure visible. And a path diagram will show exactly why omitting a variable causes bias, but it's also helpful to see the direction of the bias. So let's start without further ado by making sure that we also put a little bit of context in terms of the X, Y, and Z variables that I will generically be using for the video. We're going to start from what we have seen most of the times, a misspecified model. In the misspecified model, or the biased model, we would start by saying, okay, we want to find what is the effect on Y of a variable X. And in here, we can assume Y to be income and X to be education. So at this stage, what we are imagining is that we have a Y variable and we have an X variable, and we know the existence of this arrow in here. By looking solely at the bias model, we believe that this is beta 1. We can put hat in the case that this is our estimation. We believe that this could be the true one. However, after further looking into it, we become aware of another variable, which is a Z variable that is part of the error term in here. So it's a variable that we know affects the Y variable. However, we have not controlled for it yet. Okay, so that would mean that actually at this stage, we also have what we suspect to be a true model, a correctly specified model, which means two variables, two effects, and where beta 1 is the actual value that we want to measure. So for the true model, we will control for Z, and let's say this is Y equals to gamma 0 plus gamma 1 X plus gamma 2 Z plus an error term epsilon. So I have very specifically used different Greek letters in here for the coefficients, just to drive home again the point that what we are going to estimate here as the effect of X in the bias model is definitely going to be different from what we estimate in here. And the reason for that is because on top of Z being correlated with the Y, so affecting the Y, Z is also correlated with the X. Okay, so right now, when we simply look at the true model, it means that in this diagram in here, we also need a Z variable. And to that, we need to add an arrow that goes from Z to Y because we know Z affects Y. But again, to begin with, to have had the omitted variable bias problem, we needed to make sure that this relationship between X and Z existed, because otherwise, if we have a graph that simply looks like this, meaning I don't have a relationship between X and Z, then I don't really have an omitted variable bias problem. So how can we get a sense of like this relationship between X and Z? Well, that's where we use what we call the auxiliary model. And the auxiliary model, what it does is like says, okay, I know I have a relationship between my Z and my X variable, okay? So what that does is puts in this path diagram now the third arrow. And again, because this arrow exists, then we have an omitted variable bias. If this arrow did not exist, then we would not have had that problem. So very clearly, we can see that, well, yeah, the beta 1 that we had in here, it's clearly not going to be the true effect the moment that we don't take into account for this relationship in here. And we also know that if we had estimated the true model, then the relationship between z and y, the effect of z on y, would have been this gamma 2 in here, okay? And I can put a hat in here to say that this is what I would have estimated. Then between the z and x, I would have had in here this alpha 1 hat estimation, okay? So the bias from the previous video, we know that it would have been whatever the true beta is minus the, normally we would put the expectation of beta 1 hat here, but let's just say for now the beta 1 hat, the number. Now, in terms of actual magnitude, now we need to know what this value in here is, okay? From the explicit formula that we got last time, we know that the bias by itself is just beta 2, or in our case would be the gamma 2, since we're using the full model with the gammas, covariance between our x and z divided by the variance of x. And keep in mind, this entire thing, it's literally just giving us the alpha 1, because that is just the definition for the beta in front of the x in a regression of x and z. So ultimately, the bias that we have in here, it's going to be determined by the true gamma 2 times the alpha 1. So ultimately, the two bits of information that you can use through the path diagram to really see the direction of and the magnitude of the bias are the magnitudes of these two arrows in here, which means that if both of these are positive or negative, then you have an overestimation. And if those are of opposing signs, let's say minus and plus or plus and minus, that means that the product of the two of them is going to be negative. Okay, so ultimately the product you need to look into is the gamma 2 times the alpha 1, which again is in coincidence, or it's the same as the algebra, or what the algebra showed us in the previous video. Ultimately, if you know separately what the sign of gamma 2 is and what the sign of alpha 1 is, you can easily figure out the sign also of your bias overall. I hope this was helpful, especially to see visually what is happening with the three variables. And I'll see you in the next video with a worked example.